Hello. So today I'll talk about chapter 14.3. So this chapter is also is applying partial derivative, our new concept. So in this chapter we talked about local linearization. So this term is actually meaning to find the equation of the plane that is tangent to a curve at a certain point that we want. So this question right here, number 6 from chapter 14.3, is telling us to get a equation at this point right here of this curve that is tangent. So we know that the basic equation of plane is this, and here m here and n can be rewritten as fx and fy. So if we just replace m and n into fx and fy, we're just plugging in what the information we know, and we can get the equation of the plane that is tangent to this equation, this graph, at this point 139. So first we have to get z0. In order to get z0, we have to plug in these three. We don't have to actually, because at this point when x equals 1 and then y equals 3, z is given already, is z equals 9. So for z0 we can put 9, and for x0 here we can plug in 1, and for y0 we can put 3. Now our only concern is getting fx and fy. Now, as we talked before, fx equals derivative of this function when y is a constant and only x is changing, and fy is the derivative of this same function when x is constant and y is changing. So in order to make this easier, let's change that equation in terms of z. So we can rewrite this equation right here as z equals this. Now we can get fx, also we can write as zx. So zx is when y is constant, so when we do derivative, -1 will be 0, and also y squared will be 0 because this is constant, so it will only leave 2x. And zy is opposite. X is now constant, so -1 and x squared will be both 0 because they're constant, so only leave y squared, and the derivative of y squared becomes 2y. So these are the equation for zx and zy, and what we want for m and n here is a actual numeric value. So we just plug in corresponding point and number in this equation. So x equals 1, so we can plug 1 into x, so we'll get 2 for zx at 0.139. So here, same thing, for y we plug in 3, so we'll get 6 for zy, which is n. So now we got z0, which is 9 right here. We got m, which is fx, which we just got, that is 2. We know x0, which is 1. We know n, which is fy or zy, that equals 6, and we know y0. So we all obtained the information that we need to make an equation that is tangent to this equation at this 139 the point. So we got that fxy equals z0, which is 9, plus m, which equals 2, parentheses, x minus x0, which is 1, plus n, which equals 6, and y minus y0, which equals 3. So this is the equation of a plane that is tangent to this graph right here, this equation at this point. So if that equation is like this in 2D graph, if you look at 2D graph, and this is 139, then we just got this plane equation right now, right here, in 2D. Thank you.